Here's a counting problem. In how many distinct ways can the letters of the word Mississippi be arranged? Before we do any counting, it's worth looking at the word itself. 4 I's, 4 S's, 2 P's, and 1 M. It's actually quite an odd word when you stop and look at it. The repeated letters are clearly the interesting part. If every letter were different, this wouldn't be much of a puzzle. When I'm faced with a problem like this, I usually ask myself, what's the nearest version of this that I already know how to do? And here, that's easy. Imagine all 11 letters were different. Say we paint them so the 4 S's become 4 different shades. Then we're just arranging 11 different things. 11 choices for the first position, 10 for the second, and so on down to 1. 11 factorial, a bit under 40 million. This is where the repeated letters matter. I've counted a version of the problem where the S's have identities, where the paint tells them apart. The real word doesn't know which S is which. So 40 million isn't the answer to this problem. It's the answer to the painted one. Now I have to work out how much I've overcounted. Let's look at the P's first. There are only 2 of them, which makes them easy to reason about. Take any finished word and swap the 2 P's. Nothing. It's the same word. But the painted count saw 2 words there, one for each order of the P's. And that's true for every arrangement I counted. So everything showed up twice just because of the P's. Dividing by 2 undoes that. Now the S's. Same kind of question. How many hidden versions of this same word are there if I only shuffled the S's? Well, 4 choices for which S comes first, then 3, then 2, then 1. 24 orderings, all of them showing the same word. So divide by 24. The 4 I's, another 24. And the M is alone, so there's nothing to fix there. One thing that used to bother me about problems like this is that division shows up at all. You spend all your time multiplying to count things, and then suddenly you're dividing. Why am I dividing in a counting problem? But really, I'm not removing possibilities. I'm just recognizing that a lot of the things I counted were actually the same thing. So the whole answer is 11 factorial, divided by 24 for the S's, 24 for the I's, and 2 for the P's. I try not to multiply anything until I've canceled everything I can. The numbers stay smaller that way. Write 11 factorial out. One of the 24s is 4 times 3 times 2 times 1, sitting right there at the end, gone. Now the other 24 and the 2 written out as well. 4 times 2 is 8. 3 times 2 is 6, gone too. What's left multiplies to 34,650. So most of that 40 million was really just the same arrangement showing up over and over. If you want to try this yourself, banana is a good word for it. 6 letters, 3 A's, 2 N's. Small enough that you can actually list the arrangements and watch the duplicates show up. 60 when you're ready to check. See you in the next problem.